Good? All right, let's do this. All right, so Mr. Bedine here, Mr. M, and today we're going to be covering the anode heel effect. And the anode heel effect, again, I think the ART should kind of take that away, but we're going to discuss it because you don't really see it as much on DR systems or digital systems, but we'll talk about it today. And today we're referencing the Principles textbook. I'll show you right here. It's this one right here. And it's going to be chapter 5, and it's going to be pages 86, 87. So it's not going to be a lot of material, but we'll try to explain it as best as we can. We'll try to simplify it for you. How about that? All right, so we all know that when you take an x-ray, there's two major devices inside the x-ray tube, correct? There's a cathode and then anode, right? So I'm going to draw that here. So we'll draw a cathode here. Mine's going to be a dual filament. Okay. And then we'll have here the anode. Okay, so we know that when x-rays are produced, right, when x-rays are produced, the intensity of radiation is going to be stronger towards the cathode end. In fact, it says that it's going to be more than maybe 20% stronger on the cathode end, right, and about 25% weaker on the anode end. So you have this unevenness of energy that's coming from the x-ray tube. So because of that, if you have a body part that you're x-raying, let's say you have this body part here, you're gonna have more x-rays go through this part than you would have here. You're gonna have more attenuation because the energies are weaker. So the anode heel effect, it simply states that the energies are gonna be weaker on the anode end. So when the x-rays are produced, remember there's an angle of the anode, and some of the x-rays are being pulled behind the anode as well. So that's going to lead to a decrease in terms of a decrease of the energies. You're going to have a weaker amount of energies that are going to be going through the body part. So because of that, we can use that to our advantage. So for body parts that have unequal thickness, such as a foot, let's say a T-spine or a femur, you can utilize the anode heel effect to work with you instead of against you. So with the anode heel effect, we have a term. You always want to place the thicker part underneath the cathode, right? So we used to say fat cat, right? So you always want to go ahead and place the fatter portion of the body part underneath the cathode end. So let's say we're doing a foot x-ray. All right, so let's see if I can go ahead and do this here. All right, so here's my foot. It's been a while since I drew a foot. All right, got a little gap, but still it's foot. All right, so here we have the thickness of the body part that's going to be wider towards the heel portion, correct? And here we have a thinning of the toes, correct? So you'd always want to place the thicker portion underneath the cathode end, because the energies are going to be stronger. They're going to penetrate those thicker areas. And then you're going to have, again, these thinner parts are going to allow the weaker energies to go through. So this is going to help to create a more uniform x-ray image, a more uniform exposed x-ray image. So there's a couple body parts that we see that come up on the test questions. The foot, the AP foot is one of them. The other one is an AP T-spine. All right, so AP T-spine. So what you want to do is, how many do I got? 1, 2, 3, 4, 5, 6, 7, 8. Wait, I'm already lost count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, 12. There we go. So look at what I did here, you guys. So I put 12 thoracic vertebrae because there's 12, right? But the head end of the patient is going to be underneath the anode portion, because why? The vertebrae are smaller on that end. And towards the feet end, and this is the test questions that they ask, right? So they'll ask you which end of the patient goes towards the cathode, which end of the patient goes towards the anode. So you want to put the foot end of the patient towards the cathode because the vertebrae are bigger and they're thicker, right? So they're going to go ahead and allow those higher energies to go through the thicker body part. So again, the anode heel effect, right, is going to describe where you have a weaker intensity of energy on the anode side, so we're going to use that to our benefit, correct? All right, so this is going to be your APT spine here. All right, so this is your AP thoracic spine. So let's do one more body part here. And then we'll talk about compensating filters. So let's do this one. All right, so yeah, thick muscle here, right? Basolaterals. All right, so here you guys, look at here. We're drawing a femur. This is a distal femur. So you want to place the thicker portion of the distal femur towards the cathode end because the intensities are going to be stronger. Here, you want to place the thinner portion of the lower leg or the distal femur towards the anode portion. So again, the three most commonly used body parts that pop up on our test questions are APT spine, AP femur, and the AP foot. So again, or AP axle if you want to throw a little angle in there, right? But those are the three body parts that are used. So let's just say now that you don't want to go ahead and flip the patient. You don't want to change the orientation of the patient. This is where compensating filters come into play. So compensating filters now, guess what? We can go ahead, so let's say this is the x-ray tube. You can go ahead and place a compensating filter. So let's say this is the collimator right here, right? So this is the collimator, and then this is the x-ray tube here, right? You can go ahead and place, let's say, a wedge type compensating filter underneath it. So compensating filter, think about the term compensating. It's compensating for the unequal thickness of the body part. So a common one is a wedge. So you want to place the thicker portion of the wedge underneath the cathode end. So let's say you have the foot going in this direction. Okay, I've never drawn a foot from this direction. You can see why I don't do it. All right, so, all right, this one's funky. All right, but you get the gist of it, right? So let's say you don't want to change the orientation of the patient. Well, you can still go ahead and take an x-ray with the cathode in here, but you would place it towards the thinner portion of the patient, and you have the thicker portion of the filter to even out the exposure. You get a more uniform x-ray production going, not production, but you get an even amount of x-rays going through the object itself. So compensating filters can be used because of the anode heel effect. The most common is a wedge type fracture. We can use it for that femur that we just discussed. We can use it for the T-spine that we just discussed. There's another one. There's another compensating filter. Let me see if I can do this right. All right, it's called a boomerang filter. And what you would do is you'd place it behind the patient because this acromion area is very thin and it gets burned out. So what you can do is use a compensating filter that's a boomerang shape that goes behind the patient to make it a more uniform exposed radiographic image. So again, this is going to be a compensating filter. There's different types. There's a trough filter that can be used as well when you're doing a chest. But we primarily really don't even use compensating filters anymore. I got to tell you that, you guys, I haven't seen one used in you know, I've been in the field for 30 years. That's how old I am. So, but I haven't seen one used since then. All right, we didn't really use them even, you know, 30 years ago. But again, they're still in the reading. There's still parts of the subject matter related to the ART content, so we still kind of review it. I hope that this helps you. Please, you know, let me know if there's anything else I can help you guys out with. Thank you. Hello everyone, you guys. Thank you very much for watching the videos. I'm hoping that they're helping you out. Please make sure that you subscribe and that you hit the notification bell to be notified about new videos. Again, remember to be good to yourself and be good to others. Thank you.